I'm Dr. Brett DePoyser from the Aquarium Vet, and in this lesson, we're going to be going through the importance of ammonia in the aquarium. So what exactly is ammonia? Well, chemically ammonia is made up of a nitrogen atom and hydrogen atoms. And in our aquariums, it's present in two main forms. That's ammonia, or NH3, and the ammonium ion, NH4. It's important that we understand these two different forms because one form, ammonia, or NH3, is incredibly toxic to our aquatic animals, while the other form is less toxic. In fact, NH3 is 100 times more toxic than the NH4, and this is because it's much easier for that NH3 molecule to diffuse across the fish's gill membranes. Now, as we just saw, there is some chemistry that we need to go through in order to understand ammonia, its toxicity, and the overall nitrogen cycle. But don't worry, we don't need to be biochemists to keep our fish. Nature will do all the work for us as long as we provide the appropriate equipment, the appropriate maintenance, and when setting up a new tank, time for that filter to mature and do its thing. I have already mentioned that ammonia is important in our aquariums because it is toxic to our fish, and it can be lethal even at minute quantities. But where exactly is this ammonia coming from in the first place?
The main source of ammonia in our aquariums is produced by the fish themselves. As they digest their food, proteins are broken down into amino acids, resulting in ammonia as a waste product. Unlike in mammals, where ammonia is converted to urea and then excreted via the urine, ammonia is predominantly excreted directly into the water through the gills of the fish, and only a smaller amount is excreted in their urine. Other sources of ammonia include any organic waste in the aquarium, such as uneaten fish food, decaying plant matter, or any fish or other invertebrates such as snails that have died.
Now that we know where ammonia is coming from, let's talk about how it affects our animals. Even we are sensitive to ammonia, and if we're using cleaning products with ammonia in it, or our dog and cat pees on the carpet, we can detect the presence of ammonia at high concentrations. And other than some mild signs like irritation of our eyes, resulting in watering eyes, or maybe even to the point that we start coughing, but we can overall tolerate fairly high concentrations of ammonia, at least for brief periods. So how does this compare to fish? Concentrations much lower than those that affect land-based animals are incredibly toxic to aquatic animals. In freshwater aquariums, for example, as low as 0.02 ppm can have serious impacts on the health of our fish. From our perspective, the water could look completely normal and smell completely normal, but at these lower levels, the ammonia can cause serious burns to the gills, the skin can become damaged, and only at slightly higher concentrations the fish can die. Now, at these levels, our senses are unable to detect the ammonia, and this is why it's so important that test kits are used to measure the amount of ammonia that's present in the aquarium. Now, let's stop for a moment and discuss a little bit of chemistry and tackle the difference between ammonia and ammonium, and why this ammonia, or NH3, is more toxic than the ammonium, and how is the NH3 present at higher quantities than the NH4. And now, there's going to be a little bit of science to understand, but we're going to walk you through it, and hopefully you find it really interesting, and this helps you perfect your water quality in your fish tanks. So let's take a look at the ammonia and the ammonium ions and see what's actually happening.
In our aquariums, the ammonia and ammonia molecules are present and represented here as a chemical equation. The ammonia, or NH3 itself, is non-ionized and known as the free form, which, as we've gone over, is incredibly toxic to our fish. Then there's the ammonium, or NH4+, which is ionized because it has a positive charge. Now, in this chemical equation, we can see that this ammonia can react with water and take away one of the water molecule's hydrogen atoms, making the ammonium, or NH4. And because the NH4 has actually gained a hydrogen atom, which has a positive charge, that overall charge of the NH4 is positive and written as NH4+. Also produced from this reaction is a hydroxyl group, or OH-, and because that water molecule lost a hydrogen atom, which is positive, it now has an overall negative charge. This double arrow shows that this is an equilibrium reaction, and that the reaction moves in both directions, meaning it can move right to left and left to right. The important thing for us to know as fish keepers is the proportion of each that is in our tanks. That is the equation moving towards the left, producing more of that toxic ammonia being available, or is it moving to the right, towards the less toxic NH4? Luckily, for the most part, the most common form that is present is that less toxic ammonium ion, or NH4, and the equation generally shifts to that right-hand side. However, there are several important factors that will change that balance of the equation and determine whether or not that ammonium or ammonia ion will be present. The first is the pH, and as the pH of the water increases, the equation shifts to the left and the percentage of available toxic ammonia increases. The second is the temperature of the aquarium, and as the temperature of the water increases, the equation will shift again to the left-hand side, resulting in an increase of that available toxic ammonia. These two factors, temperature and pH, are particularly important considerations in, let's say, African cichlid aquariums and marine aquariums, which typically have a pH between 8 to 8.4, and are tropical aquariums with warmer water temperatures. In these two scenarios, the ammonia can quickly become toxic to the fish compared to a cold water aquarium with lower pH. Now, the third main factor is the salinity or concentration of salt in the aquarium. And although the effect on that equilibrium reaction is much less compared to the driving forces of temperature and pH, it is still worth mentioning. And the lower salinity will shift the equation to the left towards more toxic ammonia being present, while higher salinity will shift the equation towards the ammonium ion. We will cover some hands-on examples on how to interpret test results, taking the pH, temperature, and salinity into consideration in our lessons on ammonia testing, so be sure to check that out.
Okay, I think that's enough science for now. I really hope that you find it interesting and you can appreciate the science behind what's happening in our aquarium. In future lessons, we're going to be looking at ammonia toxicity, how the ammonia is actually affecting our fish, how we test for ammonia, and how different water quality parameters will affect the ammonia. And finally, we're going to be looking at how we deal with high levels of ammonia that are in the aquarium. And so I hope you enjoyed this lesson, and I'll see you soon.